Today I'll be performing the laboratory 5 for this subject microprocessor. So for activity 1, write and assemble a program to add the following data and then use a simulator to examine the C, H, and C flags after the execution of each addition. So I already wrote the code for this activity here in AVR Studio. So the first step is to load the value on each registers and then add the each registers. So we have to build, then assemble and run. So as you can see, there is no error. So here, there is already a value in register 16, as well as in R17, R18, R19, and R20. So the first addition is to add the value of R16 to R17, which is 23 plus 92 in hexadecimal. So after addition, the value of R17 is B5 in hexadecimal. And as you can see, there is no carry flag, Z flag, and half carry flag. So the next addition is to add the new value of R17, which is B5, to the value of R18, which is 66 in hexadecimal. So the result is 11B. And as you can see, the C flag is turned on, which indicates that the value of C flag is 1. So to properly explain, 1 plus 0 is 1, 0 plus 1 is 1, 1 plus 1 is 0. Carry 1, 1 plus 0 is 1, plus 0 is 1, 1 plus 0 is 1, 1 plus 1 is 0. Carry 1, 1 plus 0 is 1, plus 1 is 0. Carry 1, 1 plus 1 is 0, carry 1, plus 0 is 0, bring down 1. So as you can see, only the C flag is turned on, which means that the sum is greater than the 8-bit can hold. So as you can see here, there is a carry flag here. So that C flag was turned on, and the value of C flag is 1. So there is no 0 flag, and there's no half carry flag here. So H and Z flag was turned off, and the value is 0. So the next addition is to add the new value of R18 to 87, which is the value of R19. So the value of R19 is 182 in hexadecimal. And as you can see, there is a half carry, which means that there is a overflow between the upper and the lower part of the 4-bit. So there is no Z flag and there's no C flag. Next addition is to add the value of R19, the new value of R19 to F5, which is the value of R20. So as you can see here, the Z flag was turned on because there is a carry flag. So the value of C flag was 1 because the sum is greater than the 8-bit can hold. So the activity 2 was to write and assemble the following program. So use the simulator to single step and examine the flags and register content after the execution of each instruction. So all we need to do is to copy this code to AVR Studio. I already copied it, and then build, then run and assemble. So first is load a value to R20 and R21. So as you can see, there's already a value in R20 which is 27. And then we have to load the value 15 to R21. And then subtract the value of R21 to R20. So as you can see, there is no C flag, Z flag, H flag. And so the value of C flag, Z flag, and H flag was 0 after the subtraction. Then another one is to load the value of 20 to R20 and 15 to R21. Then subtract the value of R21 to R20. And then as you can see, there is a, the H flag was on because there is a half carry and there is a overflow between the upper and lower part of the forklift. So the next is to load a value to R24 and R25. And then subtract the value of R25 to R24. So as you can see, Z flag was turned on because the sum are all zeros. The next is to load the value of 50 to R22 and 70 to R23. The next is to subtract the value of R23 to R22. So here is the answer. And then as you can see, the C flag and H flag was on, which means there is the result was greater than the 8-bit encode. So the carry flag was on. And then there's a half carry, which means that there's an overflow between the upper and the lower part of the 4-bit.